We're going to take a look at a few more examples of output and formatting. And then after that, we're going to start taking a look at input. In other words, how do we get user prompts and be able to manipulate that data? And you'll probably recall that on the guided notes, a couple more examples. We want to approximate pi twelfths, and we want to give the radian and degree representation accurate to 3 decimal places and then an appropriate message. So first thing we want to do is let's just go ahead and delete everything that we've done so far because this is more of a new thing from our previous. And what I'm going to do is I'm going to define x to be equal to the sine of pi over 12. And I'm going to put that in parentheses, otherwise it's not going to work. And I'm going to suppress that. Now, to be able to get the degree measure out to 3 decimal places, we have to use the rad to degrees. So I'm going to call this pi deg is going to be equal to rad 2 deg, and I'm going to do that for x. And this one already has the radian measure because that's by default. Right? And I'm going to show you a few more things we can do with this. So we're going to do an f print f, and we're going to say the radian measure is percent, and I believe it said to 3 decimal places. Let me verify that. So it says to 3 decimal places, so percent 0.3 f, and we're going to do a backslash n so we can go to the next line, and we're going to reference x. The degree measure, we're going to copy this. I like to do this a lot to make it quicker, so I just copy and paste that. And this is the degree measure. And this time, instead of x, we're going to represent pi deg. All right. Right, so let's go ahead and execute this. I forgot a comma here and a comma below. So let's go ahead and execute this and see what happens. All right, and indeed, it gives us the radian and the degree measure of pi twelfths. Now, one of the things that we can do is we can define x to be a sim. Right, so let's do that. So I'm going to do this. I'm going to say x equals SYM. Let's see what that does to this. So I'm going to go ahead and run it. And it's thinking. All right. And it does the same thing. All right. So pretty cool that we can go ahead and be able to convert those as such. Right. Another problem that we have is we want to print the value of pi accurate to 10 decimal places. We want to print the value of 22/7 to 10 decimal places. And then we want to compute the percent error. Okay, and we're going to include a message for that, for all 3 of those. And we have our formula approximate minus actual, absolute divided by actual times 100% to be able to get the percent error. All right, so I'm going to define, let's call x to be equal to pi. And let's say y is equal to 22/7. And we're going to say, I'm just going to say error is equal to the absolute value of, the approximate value is y, the actual value is x, and we're going to divide that by x, which is the actual value, and we're going to multiply that by 100. Now that's going to give us the percent error. All right. Now we want to round everything to 10 decimal places, so we're going to need 3 f print f. So we have f print f, and we're going to say the value of pi to 10 decimal places is, and we're going to say percent 0.10 f and backslash n for a new line, and we're going to call x to be the variable that represents percent f. We're going to do the exact same thing, except we're going to just replace pi with 22/7 to 10 decimal places, and we're going to replace x with y. And then finally, we're going to do this one more time, and we're just going to say the percent error between pi and 22/7 to 10 decimal places is, and we're just going to call error this time. Right. So let's go ahead and execute. All right. And so here's our values, okay, and they're pretty close. And as you probably know, 22/7 is a rudimentary example or approximation for pi. However, not always a good one. But notice that this is the percent error, all right? So that's 0.04%, and we don't have a percent in it, all right? So what we can do is we can just put a percent right here. And notice it has 2 there, format -3. So let's just do that so that way we can get a percent in there. And let's run it again. It doesn't like it. All right, so we have to be careful with this. So after this, what we're going to do is we're going to say percent. So that way somebody doesn't think that it's just the raw value. Okay, it's the percentage, not the error. Okay. So that might be helpful for you to know is that if you put 2% next to each other, it actually represents something else in MATLAB, which we're going to see a little bit later. All right. The other thing that we're going to go through in this video is we're going to take a look at how do we get input. And I'm just going to show you the basic input commands and how we go ahead and do that. And input's pretty easy. Right? So if we want to try to prompt the user to input data, then all we're going to use is we're going to use this input command, and then we're going to have a message, and then it's going to halt, and it's going to wait for the user to enter some sort of data. And the data doesn't just have to be numeric. It could be a string. It could be a polynomial. It could be anything you want it to be. All right, that's the beauty of MATLAB. Almost always we want to assign it to a variable. All right, so in our videos, what we're going to do throughout this course is we're just going to assign it to a variable. Let's call it X. Right? So let's go ahead and just take a look at a couple examples really quickly of how to get input, and then we can start working on some more difficult sorts of examples, because we'll have input, we'll have output, we'll have formatting, that sort of stuff. So we want the user to input the length of a width of a rectangle. And then once we have that, we're going to print the area and the perimeter, as well as the original length and width, and we're going to put an output message there. All right, so here's what we're going to do with this. I'm going to delete all this. Let's say length is going to be equal to input, and we're going to tell the user to input the length of a rectangle. Right? And notice what I did here was I put a space. So I have a colon and a space. So that way, when you enter the value, it's not butting right up against the semicolon. All right, so there's a little bit. And I am going to use a semicolon because if you don't, it will echo the output. I'm going to do the same thing, except I'm just going to call length width. And I'm going to say enter the width of the rectangle. Right? And we want to print out the length, the width, the area, and the perimeter. All right, so let's find the area. So area is equal to length times width. You might have heard that formula a few times in your life. And perimeter is going to be equal to 2 times length plus 2 times width. Another formula you may have heard once or twice in your life. All right? Now we're going to print each of those out. All right? So we're going to use an fprintf. And we're going to start with the length and the width. So the length is, and we're just going to use a percent f. I'm just going to use it to default because it didn't say how many decimal places. And then a new line. And we're going to close that, and we're going to reference length. Now we're going to just copy and paste this, and we'll copy and paste it 4 times because we have 4 items, and we're going to say the width. Right. And we have the area, and then we have the perimeter. All right, so let's go ahead and execute this. All right, and notice down here in the window, anytime you do an input statement, it's going to ask you for the input of the rectangle. So let's just do something basic. Let's just do 5 and 7 because we know what that's going to work out to be. So we're going to enter 5 and then hit enter. We're going to get 7 and then hit enter. And we should get 35, and we should get 20, we should get 10 and 14, so I do 24, 35. Okay, so we get 35, and maybe I made a spelling error. Yeah, I forgot the E in perimeter. Okay, let's try that again. Okay, so we get 35 and 24. All right, so the nice thing about MATLAB is, and this is probably the first time that I've made an error in a video when I'm typing, is that it doesn't just seize up the program. Okay, it'll skip it unless it's a loop, and then unfortunately it might go into like the infinite loop mode, and you might have to break it, which I'll show you how to break it in a little bit. All right, once we get to loops. One last problem is we want to prompt the user for a temperature in degrees Celsius, and we want to convert it to Fahrenheit and then degrees Kelvin, and we want to write an appropriate output message. All right, so not too bad, nice and easy. So I'm going to say Celsius is equal to input, enter a temperature in degrees Celsius. And close that out. And we're going to say, I'm just going to call it Fahrenheit FAH because I don't feel like typing it out and making an error. It's going to be 9/5 times. Notice you have to put the explicit multiplication. Celsius plus 32. And we know Kelvin. So Kelvin is going to be equal to Celsius plus 273.15. And then we're just going to do fprintf. It doesn't say how many places to approximate to, so we're going to say the Fahrenheit conversion is, and we're just going to do a %F. We're going to close that, and we're going to call Fahrenheit. And it doesn't matter if you put a semicolon. And I'm just going to copy this, and I'm going to use Kelvin. So Kelvin conversion, it is Kelvin. I noticed that I put a %G in there instead of a %F. You're probably screaming at me on the other side of the screen. Sorry about that. I'm going to go ahead and execute this. Let's use something basic, 100. And maybe I spelled it wrong. Let's see where I might have spelled it wrong. So let's try again. All right, and I forgot a /n there and a /n. Everything else is fine. I just forgot the \n. It's no big deal. So let's do 100 again. And you guys probably remember the 212 and this guy. All right, so that's one of, I think water boils at 100 degrees Celsius. So hopefully this gives you an idea as to how to do the input and how to do the output in MATLAB, how to do a little bit of formatting. And that's all we're trying to do. We're just trying to get our feet wet, make sure that we understand some of the basics. So in the next videos, what we're going to take a look at is some more applied problems, a little bit more in depth than some of the stuff we've looked at so far. If you want to give those a try before watching the video, just to make sure that you understand it, go for it. And then maybe come back and watch the videos if you weren't able to get them to execute.